Good day, everyone. The topic of the presentation is the emergence of green skyscrapers, review of sustainable and energy efficient tall buildings of the world. So the first question that comes to our mind is, can a skyscraper have a low impact on the environment? Can these tall buildings be beneficial to the environment in any way? Because all the skyscrapers usually are acknowledged as major energy consumers with little consideration towards energy efficiency. And the overall consumption of the energy per year by the building sector alone, it accounts for 40%, which is quite high. The architects and developers in the past have been focusing on development of attractive buildings, and they have developed enormous glass facades in conventional skyscrapers, which have transformed these buildings into heat boxes, resulting in higher energy and cooling loads. Then why the skyscrapers? Now, due to the increasing population and densification of cities, we are facing the problem of urban sprawl with fragmented open spaces and hardly any breathing spaces, which leads us to the need for vertical development. And with the increasing number of skyscrapers, the energy consumption is also increasing, which leads to rapid exploitation of resources. And we do require energy conservation here. That's when the green skyscrapers come into picture. So what are these green skyscrapers? They may be defined as the buildings that are designed and developed on the principles of energy efficient techniques and green strategies, sustainability, which contribute to cleaner environment, healthier conditions, and energy conservation. Some of these buildings also produce electricity and generate energy through the renewable sources of energy, which is a remarkable feature. So some of the green strategies that are covered in this paper include vertical landscaping, climate responsive facades, wind energy and aerodynamics, and BIPV, building integrated photovoltaic. The first building that we are talking about here is Agora Garden, which is famous for its unique form and structure, and it has been designed majorly to combat air pollution. It purifies air and acts as a smog eating machine by absorbing 130 tons of carbon dioxide every year. The plantation covers an area of 6,000 square meters, and it is maintained by the filtered wastewater. It further prevents the building from the excessive heat gain and solar radiation, which reduces energy consumption. And the building is also capable of producing 130 megawatt of energy per year through photovoltaic panels, which are installed at the top of the building. Commerzbank, Germany. This is the first skyscraper, which was designed, eco-friendly skyscraper, which was designed by Foster and Partners, and it reduces the energy consumption to 45% through its natural systems of ventilation and lighting. The other features include full height central atrium, 3-layered facade system, natural stack ventilation, and operable windows, which automatically shut off the mechanical ventilation systems once the windows are open. EDITT, Singapore, has been designed on the similar principles, having a green facade, and the area of the plantation is about half of the overall area that has been covered by the building. We can basically say that the 1/3 of area has been covered by the plantation itself. Then we have a continuous landscape ramp and the garden terraces throughout the building, throughout the height of the building, and it further cuts down to the energy loads. The other features include integrated sun shading to window glazing, rain cover, rainwater catchment provision, and the shelves which bounce back the light and redirect it wherever it is required, and the photovoltaic covering an area of 855 square meters. The overall energy saving here is about 20%, and the water conservation comes to 31%. One Central Park, Sydney was developed as the first phase of a site redevelopment project. And here, the largest facade are the north and south, which provide self-shading. At the podium, at the bottom, there is an atrium, 5-story high atrium, which originally did not have any natural lighting. It was not receiving any natural light. So a 40 meters long cantilevered sky garden was projected out of the west face, which has got reflectors at the bottom, and it reflects and redirects the light to the atrium, which reduces the artificial lighting load of the building overall. The total energy saving for the building comes to 26%, and this structure has been rated 5 on the Australian Green Star standard. Alba Towers, which is located in Abu Dhabi, and it faces extreme weather conditions. It is famous for its unique facade, which is a reminiscent of traditional Arab feature, that is mashrabia. So the building comprises of weather-tight glass curtain wall, having unitized panels, which are floor-to-floor height. The moving joints connecting curtain wall and shading system comprises of innovating triangulated umbrella-like panels, which can be seen in the picture on the right. These panels fold and unfold according to the sun movement, and they are controlled by the sun tracking software. The building overall reduces the heat gain from 20 to 50% and reduces cooling load substantially by 25%, with 40% of carbon emissions saving. Burj Doha, it is again developed on a similar concept, having a continuous facade from top to bottom, you can say bottom to top. It is famous for its unique facade, which is available in the form of a perforated screen, and the pattern is repeated throughout the facade at different scales. These perforations are denser according to the sun movement and according to the local conditions. The facade is denser on the west and eastern face, which comes to about 60% of opacity, which prevents direct solar radiation, exposure to excessive direct solar radiation. And 25% to 40% opacity has been achieved on north and southern facade, which are not that much exposed to the direct sunlight. O14 Dubai, which is developed on the similar concept, but the only difference here is that the facade itself is a primary structural component, unlike any other tall building where the structural component is the core inside. Here, the facade itself is an exoskeleton made of concrete, which gives strength to the entire structure and provides column-free spaces inside with a reduced core area. The size of the openings vary according to the requirement, structural requirement, exposure to the sun, and required daylight and views. And overall saving here is about 30% in energy consumption. Bahrain WTC is another famous building of the Middle East. This is the first skyscraper to have integrated wind turbines for generation of electricity, for generation of energy. And it is also famous for its unique aerodynamic form, which is required to channel the wind towards a 29 meters turbine, which are capable of producing 225 kilowatt of energy. These towers generate up to 15% of energy requirement, and the tower produces overall 1100 megawatt of energy per year. Pearl Tower, China. The building utilizes solar and wind power both to save as well as produce some electricity. It is famous again for its fluidic form, which is actually essential for running these turbines. And the facade is enveloped with the photovoltaic panels. Other features include integrated radiant cooling, photovoltaic panels, which generate about 200 megawatt of power per year. Just through the photovoltaic, the energy generated by the wind turbines is additional. And the tower overall saves about 30% of energy. CIS Tower. This is not a new construction, it is an old building, and the original facade of the tower consisted of mosaic tiles which were replaced with the photovoltaic panels later on the east, west, and south face, as the north would not receive much of direct sunlight. The tower is capable of producing 180 megawatt hours of electricity per year. Additionally, it produces 10% of energy through the wind turbines that are installed at the top. And CIS Towers became the largest commercial solar facade of Europe. Lighthouse Tower and Burj Al Dhaka. Both the buildings are the concepts because they could not be constructed due to some constraints and economic slowdown. Lighthouse Tower on the right-hand side has got 3 wind turbines integrated and integrated photovoltaic facade, and the Burj Al Dhaka on the left has got photovoltaic facade plus wind turbine at the top of the building. Now, both the buildings were planned to reduce energy consumption from 40 to 50%. through the photovoltaic panels and their other features. Here we can see the research outcomes, and we can see that most of these buildings are from the different climatic conditions. In fact, so the energy saving, we can see the variation in the saving of energy consumption here, which ranges from 15% in case of Bahrain WTC, and it goes up to 45% in case of the Commerce Bank, Germany. Some of these buildings are also capable of producing energy, which includes Bahrain WTC, Pearl Tower, China, CIS Tower, UK. City Hall is an additional building that has been included here. It is not a high-rise building, but it is also capable of generating about 80 megawatt per year. So we have included the study in this case. And Lighthouse and Burj Al Taqwa. These buildings are capable of generating energy while saving some good amount of energy as well. And we can see that most of these buildings have actually incorporated photovoltaic and wind turbines both. So most of the buildings have actually widely used photovoltaic here and then the wind turbines. And some of the buildings have just relied on the vertical landscaping and natural systems of ventilation and lighting. But substantially, they have reduced energy consumption. So we can probably conclude here that these conventional skyscrapers can be transformed into highly energy efficient tall buildings with the incorporation of sustainability and green strategies and innovation in architecture, of course. Solar design principles, solar passive design principles, generation of energy from solar, that is photovoltaics, etc., and the wind turbines could be an appropriate solution at present in the Indian conditions for the high-rise buildings in India. We can also incorporate vegetation to purify the air, and it will further reduce the heat gain. So overall, collectively, the three strategies here, the photovoltaic, wind energy, and the vegetation can help in making the building energy efficient. Plus, incentive schemes and mass production can be very helpful. Incentive schemes in building industry will encourage architects and designers to incorporate such techniques into their building designs. And if these are mass produced and promoted and utilized well, these renewable sources of energy will be an efficient and economic solution for the building industry. Plus, in future, we can also examine social acceptability of green skyscrapers, as the concept of high-rise living is still new in India and it is emerging rapidly. So an investigation of its impact socially, culturally, and economically is essential. Further, we can explore the possibility of utilizing geothermal sources of energy. It is being used in some of the buildings worldwide, but we need to explore further about its utility and about its utilization and incorporation in the Indian context. So here are the references. And thank you very much for your time, and have a good day. Please feel free to write for any suggestions. Most welcome for all the suggestions and comments. And thank you very much. Have a good day.